May 2019 question number 5A. May 2019 question number 5A. 𝗔𝗲 tours. Very easy question, really. May 2019 question number 5A. May 2019 question number 5A. So you're told here 𝗔𝗲 Tours and Travel is a private limited company in the tourism industry. In order to improve customer service and provide the management with timely and quality information, the company is contemplating to purchase 8 microcomputers at a cost of 100,000 each. So 8 computers, and they're telling us that each is 100,000. Therefore, the total investment here, the total investment will be 8 times 100,000, which is 800,000 Kenya shillings. Page number 6, page number 6, page number 6, page number 6. So Kenya shillings, 800,000, 800,000. Kenya shillings, 800,000. So I'm trying to look at the low-hanging fruits here. I'm trying to look at the low-hanging fruits. So like that investment, not many students were able to get that right. Great. So 800,000 Kenya shillings. Now, ladies and gentlemen, we are told there installation cost for all the computers will amount to 80,000. It is estimated that once installed, the computers will increase the company's earnings before depreciation tax from 12 million to 12.5 million annually. Listen, what will I do to this installation cost? What are you normally taught in advanced taxation regarding installation cost of installing a plant item? Installation cost, they're qualifying expenses, isn't it? So in this case here, if I'm the one doing this, I'll come and say here, add installation cost of how much they have given us a figure. Installation cost, ladies and gentlemen, installation cost of how much? Of 80,000. Remember, it's not 80,000 per one. Add incidental cost. Thank you very much. 80,000. So basically, I will be able to subject the entire figure of 880,000 to depreciation. Many students in this semester missed it out. That 80,000, they got a 0. Thank you very much. Now we are told there, the computers are expected to last for 10 years, after which they will be obsolete with 0 resale value. The operations manager proposes that the computers will be useful for 15 years with no resale value. The marketing manager, on the other hand, argues that the company needs the computers for only 5 years, after which they will be disposed of at 50,000 each. The probability distribution of the useful life of the computers is given as follows. So we have the probability, we have useful life of computers 5, 10, 15. The company is in the 30% tax bracket. The company's cost of capital is 24%, and we use straight line method to depreciate. Now, when they give us tax rate, we as right-thinking members of the AFM society, what comes to our mind whenever you see a rate of taxation is given? Depreciation has to be computed. And really, that is where I will start. Compute depreciation. But remember, this is a what-if analysis question. There are 3 life possibilities. The first possibility is when n is 5 years. When n is 5 years, the initial cost will still remain at 880,000. Is there anybody who can give me the scrap value? If n is 5 years, could you kindly give me the scrap value when n is 5 years? What have they told us? When n is 5 years, what will be the scrap value? When n is 5 years, what will be the scrap value? If you look at paragraph number 4, the marketing manager, on the other hand, argues that the company needs the computers for only 5 years, after which they can be disposed of at 50,000 each. But remember, how many are they? There are 8. There are 8. So 50,000 times 8 gives me how much here, somebody? This gives me 400,000 as a salvage value. And therefore, depreciation per annum, I know that depreciation per annum will be the initial cost, which is 880,000 minus the scrap value, not 5, 15 years. You know, we have got 5, 10, and 15 years. There is 5 years, 10 years, and 15 years. I'm going to do each one of them. Each one of them. Are we together there? So now we are reading the 5 years, paragraph number 4, where one person is making a proposal that he believes that the computers will stay with us for 5 years only. We are told the marketing manager, on the other hand, argues that the company needs the computers for only 5 years, after which they can be disposed to offer at 50,000 each. So are we together, first of all, up to there? Correct. Correct. So then the depreciation per annum will be 880,000 minus the scrap value of 400,000 divided by the useful life, which is 5. Divided by the useful life, which is 5. So then could you kindly give me the depreciation per annum? Kindly give me the, somebody is giving me a figure of 96,000. Somebody is giving me a figure of 96,000. Thank you, and thank you very much. So this is 96,000 like that. Thank you very much. Now, how about this other scenario when n is 10 years? When n is 10 years, are you able to see the metrics now? When n is 10 years, I know that the initial cost of these computers will still be 880,000. How about the scrap value? 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 We have been told in paragraph number 3. Paragraph number 3, the computers are expected to last for 10 years, after which they'll be obsolete with 0 resale value. So resale value or scrap value is 0. And if that is the case, then could you kindly go ahead and give us depreciation per annum? I'll still use this formula. It is the initial cost of 880,000 minus the scrap value, which is 0, all over number of years, which are 10. Number of years, which are 10. All over number of years, which are 10. So somebody is giving me a figure of 88,000. From there, ladies and gentlemen, lastly, now we have Winnie giving me 176. I don't know where Winnie is getting 176 from. I don't know. 88. Okay, great. Now from there, we have the last n, which is 15 years, the one you guys were talking about. So still the initial cost here will be 880,000. How about the scrap value? How about the scrap value when n is 15 years? Scrap value when n is 15 years. The scrap value when n is 15 years will be how much? Somebody talk to me tonight. Talk to me tonight, somebody. Talk to me tonight, somebody tonight. You have to talk to me. So in this case here, if it's 15 years, scrap value, they're telling me that this thing will be too old to have any value. So 0. And if that is the case, then could you kindly give me the depreciation per annum? Could you kindly give me the depreciation per annum? These are the low-hanging fruits that I expected my students to go and harvest while smiling. So depreciation per annum here will be 880,000 minus 0 over 15, which somebody is able to give me a figure of 58,667 Kenya shillings. Thank you very much. Those are quite low-hanging fruits. Now, after that, ladies and gentlemen, number 1, they want me to give them the expected net present value. They want me to give them the expected net present value. There is no way I will be able to give them net present values of these economic lives without giving them the cash flow statement. So the first thing that we need to do is to provide a cash flow statement, which is quite a simple thing to do. So mention their cash flow statement, mention their cash flow statement, mention their cash flow statement. Are we there? Mention their cash flow statement, cash flow statement. So my cash flow statement, ladies and gentlemen, is quite a simple thing. They have told us in note number 2 that Note number 2, installation cost for all the computers will amount to 80,000. It is estimated that once installed, the computers will increase the company's earnings before depreciation and the tax from 12 million to 12.5 million. Check this. We have brought in computers. These computers, we are told, ladies and gentlemen, that they will push our earnings from 12 million to 12.5 million. Then what is the net benefit of installing these computers? What is the net benefit of installing these computers? What is the net benefit? 500,000 increase. Now we are together. 500,000 increase. So come and give us, ladies and gentlemen, come here and give us this working here of our cash flow statement when n is 5, when n is 10, and then when n is 15. How does our cash flow statement look like? Our benefit is the annual, the increase, the annual profit before depreciation and tax. 500, no problem, Mayom. 500,000, they have told us, paragraph 2, that our earnings before depreciation and tax will increase from 12 million to 12.5 million. The increase there is 500,000. The increase there is 500,000. Are we together, Mayom? Are we together, Mayom? The increase there is 500,000. Are we together? Are we together? Great. So in this case here, the increase here is 500,000. So we have 500,000, 500,000, 500,000, 500,000. Great. 500,000, 500,000, 500,000. Remember, it's annual, eh? So don't multiply this with 5, multiply this 10. I saw so many students doing like it's annual, it's every year. It's every year. Why not to use? You see, the computers, when they come on board, Mayom, they're not going to increase revenue by 12.5 million. We know without computers, we've been getting 12 million. When computers come on board, we shall have now 12. So the increase, the benefit of these computers is only 500,000. So I shall be comparing the benefit of these computers vis-a-vis what are the costs. 12.5 is the whole. Great. Now, ladies and gentlemen, having gotten this, what do you think will be the next thing to be done? Somebody talk to me tonight. I want to get cash flow statements. Remember cash flow statements, less depreciation. Thank you very much. Less depreciation. It's also per annum. This is per annum. Are you able to remind Mwalimu these depreciation amounts we got? Depreciation amounts we got. Are you able to remind Mwalimu? The first one is coming to 96,000. The second one, when n is 10, 88,000. Thank you very much. The third one, is there somebody who can remind Mwalimu the third one? 5667, 5667, like that. So you subtract this, ladies and gentlemen, quite first for you to be able to give us, the profit before tax, the profit before tax of 5867. Sorry, 58,667. Thank you very much. So come here and give us now the profit before tax quite fast. Somebody give me the figure. 404,000. 404,000. 404,000, yes. How about when n is 10? When n is 10, we have 412,000. 412,000. When n is 15 years, 441, 333. Thank you very much. Now I've been able to get profit before tax. So what do you think then will be the next thing to be done? What do you think will be the next thing to be done, having gotten this profit before tax? What do you think will be the next thing to be done? We subtract taxation. We will come here and less tax. The tax given there is 30%. The tax given there is 30%. So please knock 30% here. Knock 30% there. Please, when the number is this big, try to avoid putting your cameras on. Try to avoid putting your cameras on because my internet is already on the red. Always ensure that your internet 112, 121, 200. Somebody is giving me a figure of 121, 200 there. How about this one? Somebody, the tax here. The tax here. The tax there. 123, 600. 123, 600. How about the tax here? How about the tax here? How about the tax? The last one here, 30% of this. 30% of this. 132, 400. 132, 400, I don't know. 132 for approximately. So please, could you kindly come here and give us the part? Come here and give us the part, the profit now after taxation. So 404 minus this, what figure are we getting? Betty tells me 282,800. 282,800. That's Betty giving me a figure 282,800. How about 288,400? I don't know. 288,400. 288,400. The last one. 282,800. 282,800. Okay. The last one, 309, 308, 933. 308, 933. Can somebody confirm that all these figures are correct before we move on? Can somebody confirm that these figures are correct? Yegon says, yes, correct. Sure. Thank you very much. So having gotten profit after tax, what do you think will be the next abracadabra that we should do? We add back, you guys are geniuses. Add back depreciation. Add back depreciation amounts. I have them here. 96,000. I have them here. 88,000. Thank you so much. I have them here. 58,667. So, ladies and gentlemen, then could you kindly come and add them for you to give us the operational cash flow? For you to give us the operational cash flow. For you to give us the operational cash flow from our operations. Cash flow, Ruth tells me 378,800. 378,800. My work today is so easy. 378,800. How about when n is 10? 376,400. 376,400. How about the last one? 367,600. 367,600. The last one is 367,600. Ladies and gentlemen, after getting this, what do we do? After getting this, what do we do? We discount. I like that. Discount. I like that. Discount them. Discount them. Yeah. So in short, somebody is telling me to come and provide here PVFA. We use PVFA. Is it going to be PVFA or PVF? Is it going to be PVFA or PVF? Is it PVFA or PVF? It is PVFA. Why? Simply because whatever figures we have here, like this is an annual cash flow. We are going to enjoy this cash flow every year for how many years? 5 years. There are annuities years. You can even remember this was an annual profit. This was a depreciation per annum. So these are annuities which are independent. Somebody some time back here was telling me, Mwalimu, but this figure is dancing. Which kind of dancing is this? These years are independent. They're independent. So I'm supposed to look at this particular period here in isolation. So I'm going to use PV. Ladies and gentlemen, have they given me the cost of capital? Have they given me cost of capital here? Have they given me cost of capital here at 24%? Thank you very much. So I would want some good student to come and read PV for here, 24%, 5 years. I'm so sure this 24% is there well within there in our tables. Is there somebody who is able to confirm the PV FAR, whether we have 24% in our tables? Please, everybody, check whether we have 24%. Everybody. Do we have 24% on our tables? Lucy Allen says yes. Bila Wairimo says yes. Yes. Maureen says, how comes it's only girls? Boys, where are we? We don't have tables, boys. What if we use a calculator? If 24% is in your tables, usage of a calculator is waste of time. It is there. Thank you very much. Boy, child. So 24%, 5 years. What figure do we have there, somebody? 24%, 4 years. I can see there 2.7, 454. Thank you very much. So please 24%, but when n is 10 now, 24% when n is 10. 24% when n is 10. 24% when n is 10. When n is 10, I can see somebody who said 0. Najua umekosea, wewe hujaangalia table yako. Sio lazima uangalie table uone annuity. Soma table ya annuity. Hapana soma table ya lump sum wewe. 3.6819. 3.6819. 3.6819. How about when n is 15? How about when n is 15? Still 24%. 24% is cutting across. 4.00, 4.0013. 4.0013. 4.0013. So are we together up to here? Are we together up to here? Are we together up to here? Are we together? Great, great, great. Ladies and gentlemen, if we are together up to there, then I would want us to give them the present value. Present value. My space is quite nice. So I want you to give us the present value of operational cash flows. Give us the present value of operational cash flow. Of operational cash flow. What are you doing? You are taking the figure you have here times this. Give me a figure in 2 decimal places. This times this. What are we getting, somebody there? I can see 103.9957. 103.9957. 103.9958. Let me even put whole numbers. 58. How about the second one? This times this. Please give me a figure. Whole number. Give me whole number. This times this gives me what figure? This times this. 1385.86. 1385.86.7. 1385.86.7. 1358 or 85. 1385.86.7. Yes, I picked it right. Thank you so much. So from there, come and give me this and this. Please multiply them. This and this, multiply them. So somebody gives me a figure of 150. 147.088. 147.088. The last one. 147.08. 147.0878. 147.0878. 147.0878. Thank you very much. Thank you very much. Thank you very much. Thank you very much. Ladies and gentlemen, remember these are present values from operational cash flows. In this question, do we expect any other cash flows other than these cash flows from operations? Yes, I can see Caroline telling me that we have some cash flow that 100.1% of students forget. The terminal, the cash flows, terminal cash flows, terminal cash flows. So terminal cash flows, terminal cash flows. If you allow me, I'll come here and try to create some space by coming and saying here terminal cash flows C. So the terminal cash flows, the terminal, what we call the TCs, terminal cash flows. Terminal cash flows. So when N is 5, is there anybody who is able to remember what the scrap value was? If N is 5, what is the scrap value? 400,000. Thank you very much. And then, of course, the others, the scrap values were what? 00. So having written that, could you kindly advise me, what do you think will be the next thing for us to do? Having identified our terminal cash flows, what should we do next? Thank you very much, Abdul. That for scrap value, we shall use we shall use no scrap, no tax shield there. No taxman can allow you to claim something there in finance. Okay, so it is PVIF. So come and discount this. So please give me the present values, interest factor of the terminal cash flows. Remember here, the PVIF will be PVIF 24%, N is 5. Here we are not going to use PVIFA because the 400,000 is not a repetitive figure. The 400,000 will only come to us one off at the end of year 5. Right. So in this case here, they are telling me that the PVIF, this lump sum amount, PVIF is 0.3411. PVIF is 0.3411, right? So then could you kindly give us the present value of the terminal cash flows? Of course, these are nothing really. It's only this times this times this, these two multiplied, those two multiplied. What are we able to get there, somebody? 136, 440. 136, 440. Thank you very much. Ladies and gentlemen, could you kindly then advise me? Now there I am, honestly stuck, not knowing what my next step will be. Just like how everybody else would pass the ball, football to you. And there you are right at the middle with no goalkeeper. You are stranded. You don't know how to kick the ball, right? So somebody is telling me to less IO. Add. What they're telling me now here, I understand. These are bright students. They are telling me, Mwalimu, you know what? We are very bright. What we do is to come here and ascertain the total present value, which will be the present value of operational cash flow, plus present value of scrap of the terminal cash flow. Tukianza na N equals 5, the total present value will be equal to what here, somebody, when N equals 5? When N equals 5, if you're using this, what will be the total present value? When N is 5, what will be the total net present value? What will be the total net present value? Unachukua woye, unachukua ile ilikuwa hapa present value of operational cash flow. Ile ilikuwa ya 103, 99, 58. Unasema plus 136, 440 woye. The figure they're giving me is 1176,398. 1176,398. Thank you very much. How about the total present value when N is 10? When N is 10, fortunately, we know that when N is 10, we don't have scrap. When N is 10, the total present value remains just this that we had down here, 13, 85, 86, 7, like that. The same, when N is 15, the total present value will be equal to 1470, 878. Thank you, and thank you so much. So then could you kindly guide me, after having gotten this to this stage, what will be the next thing to be done? Great. Less initial outlay, get net present value. Why don't we do annual cash flows? I don't understand your question, GX, please. But unless somebody can help me, why don't we do annual cash flow? I don't understand that question. Maybe if I could just relax a little bit to give you more time to even type. At times I could be speaking too fast. So please type your question nicely. And then remember, for the new students, we have very good videos of this discounting. The new students, you need to really watch those videos. How many types of cash flows do we have? We have operational cash flows. operational cash flows coming out of our revenues. And then we have, of course, the terminal cash flows and the initial outlay cash flows. All right. All right. So come here now and work with the last type of cash flows, which really is a subtraction of what here? The initial outlay. So come and give us, ladies and gentlemen, net present value. So give us the net present value, which will be equal to the total present value minus the initial outlay. Minus the initial outlay. So again, as usual, we start with n equals 5. So when n equals 5, the total present value is given here. 103, 99, 50. No. Quite wrong. When n is 5, this is the thing. It is 1176, 398 minus the, is there someone who can remind me the initial outlay? Initial outlay was 800. Initial outlay was 800 and something, 880,000. 880,000, thank you very much. So then could you kindly come and give me this net present value when n is 5? So when n is 5, what is our net present value? 296, 398. 296, 398. 296, 398. So could you be kind by going straight away and giving us initial cash flow ndio hiyo initial investment. Ndio initial investment. Ndio sawa na initial outlay. Ndio sawa na initial outlay. Great. So go to when n is 10 years. When n is 10 years, what do we have there? When n is 10 years. So when n is 10 years, my net present value will be equal to the total PV at 10 years was 1385. 1385, 867 minus the 880,000, which is the initial outlay, of which I'm seeing so many guys have already given me an answer. They are telling me, Mwalimu, you know what? We know that this one is supposed to be 505, 867. 505, 867. When n equals 15, NPV will be equal to, I know the total net present value is 1470, 878 minus 880,000, which will end up giving me what figure? Somebody, which will end up giving me 590, 878. 590, 878. But now, ladies and gentlemen, if you look at the question was not about just net present values. The question was not about just net present values. Read the question again. You'll see exactly what the question needed you guys to do. You'll see exactly what the question needed you to do. Very good. Carole Mosioka, you've understood the entire thing. Caro amejua, this is expected net present value, and she has sung the chorus, ta-ta, like that. That we already have the probabilities. The probability, remember the probabilities have been given, that if n is 5, probability has been given there. Probability has been given there. Probability has been given there that when n is 5, the probability is 0.2. When n is 5, this n here. So then I should come here and pick the NPV of this 5, multiply it with the probability. And then the NPV of 10, I know the probability there is 0.5. NPV of 10, I know the probability here is 0.5. And then we have an NPV of 15 times 0.3, like that. Therefore, expected NPV will be equal to what? Therefore, expected means average. Expected NPV here will be equal to, we have 296, 398 times 0.2 plus the one of 10 years. The one of 10 years is 505, 867 times 0.5 plus 590, 878 times 0.3. Could you kindly give me this expected net present value? Expected net present value. Expected net present value. Wananiambia ni 59, 59, 59, 59, 279. 59. Wananiambia mwalimu, this is 59. The total answer. 59, 279, 279.6. Like that. Please underline. Underline. The total. You know, I've added. Please don't do kando. I've added. You can see here there is a plus. There's a plus. So I expect you to take this, multiplied plus this, multiplied plus this. The final answer. The final answer. The final answer. The final answer. The final answer is not this one. I want the final answer. Expected. Expected. So the expected NPV, ladies and gentlemen, in this question is 489, 477. 489, 477, like that. And because it's positive, it means at the end of the day that this project NPV is positive. NPV is positive, and therefore project, and therefore the project is what here is viable, and therefore the project is viable. Just that, the project is viable. Thank you so much. Thank you so much. If you allow me, I'll want to go to part 2 of this question, where they ask students here to do something very little, where they asked us to give them the standard deviation of net present value. So the first question that I would want to throw to you, great students of this AFM community. You know, AFM community is a community of geniuses, right? So could you kindly give me that master stroke of a genius by giving me the formula of standard deviation? Standard deviation. So I can assist you. Thank you so much. Thank you so much. So wanasema mwalimu, this is quite an easy thing. By definition, even from high school, we used to be told that standard deviation means difference. Deviation is to subtract. That take x minus x bar, you square, all right? And then you sum them. Because we have probabilities, of course, you'll come and multiply this with probability. And then at the end of the day, there must be a square root. There must be a crypto root. Kama ni mtu kutoka Kalenjin land, tukisema square root, yeye anasikia ni crypto root. Kamnyama kingine kadogo namna hii. Kamnyama kingine kadogo namna hii. Mimi najua kikale mingi. Najua kikale mingi sana. Hata Kikuyu hapa, there are very few students wanaweza kunishinda kuongea Kikuyu. Tena mimi naongelea ndani ya Nyeri. Nikipata mama ambao nilika mama yangu, namwambia 𝗙𝗂𝗄𝗏, anakuambia 𝗙𝗂𝗄𝗏. Wanafunzi hawajui mother tongue zao. Hawajui mother tongue zao. May take time nasoma. Siku hizi kuna translations. So najua vitu mingi sana. Vitu mingi sana. Vitu mingi sana. Yes. 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 Aya. Sasa unakuja hapa, unajua hii itakuwa ni standard deviation ya net present value. So itakuwa difference between the NPV that you have. X bar means expected net present value. Expected net present value. Great. So you see X bar is the same as what here? Expected net present value. Is it okay now? Is it okay now? I was changing battery. Technology. So expected net present value. It is our X bar average. And then we square times probability. And then of course kuna summation hapo. Alafu unakuja unadunga ka square root pale juu. Haya, hebu nikumbusheni mwalimu, net present value zetu zilikuwa gani? Zilikuwa 3. Oye, unazikumbuka kweli zile net present value zetu? Umesahau. Unakumbuka net present value zetu? Yes. Ya kwanza ilikuwa ni 296 39.8. Ya pili ilikuwa ni 545.867. Ya mwisho ilikuwa ni 590.878. Unakuja unasema minus. Is there anybody who is able to see the expected net present value? Expected net present value. Unaiona kweli mahali? Hii tulikuwa nayo hapa. 489, 477. This one does not keep on changing. This one are backing the same. 489, 477. And then you'll come here and square whatever numbers you get. You square them times their corresponding probabilities. The first one probability here is 0.2. The second one probability is 0.5. The third one probability is 0.3. So could you kindly give me these humongous numbers? Remember, it's NPV. I'm simply using this formula, NPV minus ENPV. And then I square times probabilities, big numbers, times probabilities. It doesn't matter really. No, you cannot get square root for each one of them. Remember, Meshach, square root comes after you have added. Square root will come down here after we add. You take this minus this equals, you square, whatever you get times 0.2. Please give me a number to write. Don't worry. I'll be able to copy that number down. That's quite a small number. Why were you crying? 74, 55, 900. 74, 55, 900. 74, 55, 900. How about the second one? You take this minus this, say equals first, and then you say squared. Whatever you get there, you multiply it with 0.5. What are we getting there? Somebody help me out, please. 13,431. 13,431, 6050. A beautiful number. How I wish I could get this kind of money. I mean, I would be happy. This one, I should get it. I proclaim it. How about the last one? Amen, yes. How about the last one? Beti nikipata nitakugawia. The last one. Quite a huge one now. Quite a huge one. Used expected NPV. There's a question there. Thank you very much. I get your question. So the second one, third one, I'm told is 3084, quite a beautiful one. 308464, 308464, 8840, quite a huge one. 308464, quite a huge one. 308464, 8840. Now, there's a gentleman, listen to me very well. There's a student here called John Kamau, who is asking, Mwalimu, a good question here, and I would want you to help me answer this question. I would want you to help me answer this question. I would want you to answer this question here. Like now, this good gentleman called John Kamau is asking, why do you not take 296, 398 minus expected NPV for the first one, right? This one here, put here. Second one, you put expected net present value for the second one. The third one, you put expected net present value for the third one. Can somebody help me? Can somebody help me answer the question? Can somebody help me answer the question? Can somebody help me answer that question? It's because of this 𝗕𝗂𝗃𝗃 thing you are taught in high school, this X bar, X with a bar. X with a bar means a flat thing. This X bar has to be constant throughout. It has to be for the whole project. You can't have X bar being a different figure between the various scenarios. It cannot work. The moment you get yourself having X bar being different between the figures, please run away from that question because you are doing the wrong thing. It has to be the average of the whole project. So 𝗕𝗂𝗃𝗃, are we together there? 𝗕𝗂𝗃𝗃, are we together there? The first one I'm being told is wrong. It's supposed to be 74,55,900, 74,55,900, 0.48. Quite a huge number. Quite a huge number. Now then, could you kindly do me a favor now? Please go ahead and add the 3. Go ahead and add the 3. Add the 3. I even don't want you guys to give me the total. I don't want the total. What I would want, once you've gotten the total, please say square root. Say square root. After you've gotten the total, say square root. I'm interested in the square root. Whatever total you get here, say square root. Give me the standard deviation. Say square root of that number. Give me the standard deviation here. Give me the standard deviation here. 56, 802. Now they're giving me different figures. Remember, we get standard deviation not for each one of them. We get standard deviation after adding the 3. Look at this sigma. First of all, you add the 3, get the total, and then now you pull out the standard deviation. You pull out the standard deviation. Are we able to get this standard deviation correctly? I'm being told the answer is supposed to be 103,319. 103. I agree with this. This is the correct figure. 103,319. 103,319. They are still insisting on 56. So then could you kindly do me a favor? Could you kindly come and then give me the total, because now I can see people are disputing. Please give me the total of the grand total. The grand total. Please give me the grand total. This plus this plus this. Give me the grand total. Give me the grand total. The grand total. Is there somebody who can give me the 10,067? 10,067. 10,067 numeroid. Total figure. When you add the 3. They're telling me it's all 10. They're telling me, Mwalimu, you know what? That figure is wrong. They're telling me, Mwalimu, you know what? It's 322. Is the last negative. We can never have a negative figure when you have squares. Never, ever. And I know the mistake you're doing. Simply take 598.78 minus 489, 477, whatever. Square. First of all, say equals, and then you square. And then you multiply with 0.3. When you square, you kill. When you square, you kill. When you square, you kill. When you square, you kill what here, the negative. So now he's telling me the truth, and I don't know even who to believe. I don't know who to believe. I don't know who to believe. The total here, just take these figures the way they are, 0.48. The total. Ningejiamini Abdul kama mko na figures same nyote. Hamna figures same nyote. The correct one is 106. 106. Try this. 106. Something like that. So then could you kindly give me the square root of that 106? Give me the square root of that 106. I'll simply say square root answer. Square root answer. Square root answer. When you say square root answer, what are we getting there? 103,319. 103,319. 103,319. Now they're coming with the figure. 103,319. 103,319. Eric is still getting that. Oh, that is the no problem, Eric. What you're supposed to do is now to say square root of that answer. Square root of that answer. Thank you very much, Catherine Njoki. Thank you very much, Yegon. Outa, 103,319. 103,319. The first one is 74. Yes, I corrected. The first one, 74. I did some correction here. Even if my figures are wrong, let your figures be correct because I don't have a calculator. I've seen. Thank you very much. Eliza Mushemi. Hakuna decimal wapi hapa, hakuna decimal. Hebu niambie ni wapi hakuna decimal nitoe. Hapa. Hii inafaa kuwa comma. Mimi sitaki kwenda. Kuna decimal hapa. Hapa inafaa kuwa decimal. No. Inafaa kuwe continuous 048 whatever. The correct answer I'm being told here is 103,319. Jabir is saying that the total is wrong. Jabir, acha nikuambie. Hata kama wanasema njia ya kwenda mbinguni ni nyembamba, ati ya kwenda jehanamu ndio pana. Wengi hawezi wakakosea. Wengi hawezi wakakosea. Trust you me. Wengi hawakosei. Great. Thank you so much. So at least I've been able to get this number. So can I rub this? Yes. Now, ladies and gentlemen, we go to the last one. The last one is quite an easy one, which everybody will be able to get correct. Nobody gets this thing wrong. The last one. Wanasema, if the net present value of the project is less than 200,000, the firm will be exposed to a financial distress. Determine the probability that the firm will avoid financial distress. Assume a normal distribution. Now, before I show you how a normal distribution looks like, do we have an abnormal distribution? Normal distribution ni ile kaugali kamluya. Kwa hii class hapa kuna mwanafunzi ameshaonja ugali ya mluya. Iko symmetrical, very smart. Iko wengine hapa najua tukipika ugali mtatuitia siku moja, lakini inakuwa ni abnormal distribute. Akaro hapana. Hakuna mkamba anaweza pika ugali kama mluya. Si kwa ubaya, lakini kila mtu akona talent yake. Kama ni mcost, for example, ukiuliza Abdul, atakwambia mcost akianza kupika kama ni whatever, anapika vitu na mawali namna hii tangu asubuhi mpaka saa 7. Anaweka moto kidogo namna hii. Wako na patience. Right? Charity Njeri sisi kwanza nyinyi Njeri sasa ndio wazuri zaidi kwa ugali. We shall overcome. Now, this normal distribution is defined by two things. It has the mean and it has standard deviation. Always. Supu ndio mingi, yes, bila umesema ukweli. Thank you so much. Supu ndio mingi. We shall overcome. So, when you see a normal distribution, always we must have the mean and we must have the standard deviation. Always. Is there somebody who can give me the mean that I'm going to use? You can write this U in full. It means mean. Is there somebody who can give me the mean that I shall use here? Is there somebody who can give me the mean which I will use? Great. It is expected net present value. Expected net present value. Ambapo niambie ilikuwa ngapi somebody? 489, 477. 489,477. How about this standard deviation? We have just obtained it up there. The standard deviation nafaa kuwa ngapi? Standard deviation 103,319. Lucy usiwache kitu ku understand. Understand. Kitu ambacho unafunza dakika ya mwisho ujue ni rahisi na it's very important for you. Anything that I teach in the last minute. Number 1, know that it's very easy. Number 2, it's very important for you. I'm going to kuacha hii. Yeah. What figure have they, in this case, here mentioned in the question? They have mentioned 200,000. So, utapata, Satan is real. Utapata mwanafunzi from nowhere, amekuja hapa, anachora tu, anaandika hapa 200,000. Alafu unamuona kwa exam, amepiga smile. Amefurahi sana, kama amefanya kitu ya maana sana. Sasa wewe 200,000 iko wapi? Si 200,000 ni ndogo kwa 489. Si inafaa kuwa hapa wewe. 200,000 inafaa kuwa hapa. Ni kidogo kwa hii mean. like that, right? Ni kidogo, inafaa kuwa hapa. Na kama ni hesabu ya Mluya, ladies and gentlemen, kama ni hesabu ya Mluya, ladies and gentlemen, lazima ushade the wanted area. Wanted area. Which area should we shade here? Which area, according to what the examiner is telling us? Which area? Shida yangu ni shading. Which area should we shade? Which area should we shade? The examiner anasema, if the net present value of the project is less than 200,000, the farm will be exposed to a financial distress. Determine the probability that the farm will avoid. Ladies and gentlemen, right? Yes. But if, for example, we have our NPV being less than 200,000, then we shall suffer financial distress. And they would want us to avoid this financial distress. We can only avoid the financial distress if we play our ball around this area. So you've shaded what you would want to eat, but this is very big for you. Very big for you. So you shade the entire right. Upper, some ladies, I'm talking to you, some ladies, I know you guys are very neat, but at times your neatness really becomes an impediment. Utapata sasa some ladies hapa, unamwambia shade right, say anakujanga namna hii sasa ana hivi. Sasa ati hivi sasa ati ameshade. Sasa hili kitu gani unafanya? Na tumesema kitu, it is you being more than 200,000 US. So it should be the whole thing, and don't use a ruler. Don't use a ruler. It should be the whole thing, and don't use a ruler like that. Also men, I doubt. So thank you. Now, after reaching there, ladies and gentlemen, what do you think should we do next? What do you think should we do next? Estanasema stop. What do you think should we do next? Hesabu ya Mluya ndio mwisho wa reli. Once umefanya hesabu ya Mluya, umechora ugali ya Mluya namna hii, the next thing unajua ni Z. The next thing unajua ni Z. What else do you need? Ukishakula ugali ya Mluya, wewe sitaka kula mwingine. You standardize neighborhood. Thank you very much. It is about Z. And how do we get Z? Is there anybody who can remind us the formula of getting Z? Is there anybody who can remind us the formula of getting Z? From your CPA section 4, from your advanced MA, is there somebody who can remind us the formula of getting Z? Ah, great. It is X minus mu, or X bar, that is X minus mu divided by standard what year? Deviation. Divided by standard deviation like this. Thank you so much. Nikitambo sana, but you are overcoming. This thing will take you places, Lucy. Places that you've never seen with your eyes before. This, like where? ISPAC membership. ISPAC membership. This, just cramming this last minute. ISPAC, the last minute, yes. CPA Kenya, yes. Cram this, right? So in this case here, my Z will be equal to, from your understanding, what will be the value of X here? From your understanding, what will be your X value here? 200,000. 200,000 minus the mean. The mean is here, 489, 477 divided by the standard deviation, which is 103, 319. Could you kindly do me a favor? Kindly give me this Z in 2 decimal places. Give me this Z in 2 decimal places. Give me this Z in 2 decimal places. What are we getting there, somebody? Give me this Z in 2 decimal places. Z in 2 decimal places. Karen says minus 2.80. Minus 2.80. So please remember, as you're calculating this Z, first of all, you must give us the numerator difference alone. You say 200,000 minus 489, 477 equals whatever you get there, you divide now by 103, 319. So all of us, thank you, Stephen. All of us, I hope you're able to get a Z of negative 2.80. Is that okay? Now, from there, ladies and gentlemen, I expect you to now pick your normal table. 100, and standard deviation is 20 days. If units given are 100, and the standard deviation is 20 days. I don't know the context that you are really putting your question across here, Mayom, but standard deviation, no, don't multiply. So long as I have the mean, If mean is in number of days, for example, 20, and the standard deviation there is given, don't multiply. So we have here minus 2.80. This is it. I know, ladies and gentlemen, if this is the case, the next thing should be for me to get the entry. So please go to your normal. Ile imeandikwa normal table. Ile imechorwa kale ka ugali kamluya kule juu. Is there anybody who has that table? Is there anybody who has that table? Do you have the table, Mayom? Fine. Will normal table be provided? Yes, you will be given normal table. You will be given normal table. When they give you black scores is when they try to, Abdullah Mesema 0. Great. So please go and check out your normal table. I go kwa swali. Go and check out your normal table. So we have here the entry. So ukienda kwa normal table yako, utaona mahali imeandikwa Z. Uende paka mahali imeandikwa 2.8, hakuna negatives kumbuka. Na hapa kuna mazero, ameanza 0, 1, 2 like that. So unaenda kwa hii 2.8 na hii intersection unasoma the figure that is right at the middle there. Right at the middle there. Where Mayom, acha uoga Mayom. Mayom angalia. Enda mahali imeandikwa, Mayom unaona mahali kuna Z. Enda tu chini utaona 2.8. Right? 2.8. Right? So from there, ladies and gentlemen, unakuja sasa hapa namna hii unaangalia column kuna ka 0 pale sababu ni 2.80. Halafu nasoma the entry which is there. Unasoma Mayoma, I'll be so happy nikiona umeipata. I'll be so happy. It's okay, great. Thank you very much. Great. So hii entry wameniambia mwalimu ni 0.4974. And remember what you are told in your CPA section 4. You are told whatever entry you read is the area between the two numbers that you have subtracted. The entry that you have read from that table is the area between the two numbers that you have subtracted. So whatever you have read there is 0.4974. Then what do you know about this other half area? Kama ugali ni mluya ukweli. What is this half area from here to the infinity? Kama ni ugali ya mluya kweli, wanasema ni 0.5. And then what I want is the total shaded area. Is it possible somebody to send this normal table to our group? Is there anybody who has this normal table? They send it to our group. There is somebody there who does not have this normal table. Somebody, please help me out. I would be very happy. I'll be very happy if I can hear some students telling me that this table has been sent in the group. I'll be so happy. I will be sent. Thanks, Shem. 0.5 ni mmepata aje? Bila 0.5 ni ugali ya mluya. Ukikata inakuwa 100%. Imejaa sahani mzuri. Ukikata pande hii katikati kabisa inakuwa 50%, inakuwa 50% bila. Right? Kwa hivyo hii pande ni 0.5 na hii ni 0.5. So what I took here is this half area from here onwards is 0.5. And then of course from here to here, we can see that it is the entry area. And then now we'll be able to give them the total area. Good questions. The total area will be the shaded area, which will be 0.4974 plus 0.5, which is what here, somebody, before I answer your questions. 0.9974. 0.9974. Thank you very much. So students are asking me good questions here. Mwalimu, when do we subtract 0.5? If, for instance, you have this kind of an arrangement, and then we have, for example, Z here is 1.92, all right? And then they have given you this as the shaded area. So this is X here, this is U there. So could you kindly give me the entry here? Please give me the entry of 1.92. Is there somebody who can go to that table where Z is written 1.9 And then we have, remember, the second decimal place comes there. So 1.92 is there. So can somebody in this case here give me this figure that you are seeing there? Somebody, 0.4726. So this is 0.4726 like that. So this is the entry 0.4726. But now remember that the entry you have read is the area between what and what? Is the area between the mean and X. So whatever you have read here is here, 0.4726. And yet the examiner wants the shaded area. So in this particular case, how do I get the shaded area? Knowing that the two must add up to 0.5. 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 So in that case here then, because the two must, this is A, this is B. We are saying that A plus B should be equal to 0.5. And then we know that A is 0.4726 plus B should be 0.5. Therefore, B will be 0.5 minus 0.4726, like that. And then you get your answer. All right. Point 9726. 0.9726. I'll be able to explain that. Mayom have gone ahead in this case to look at a different example. A different example, just hypothetically here, whose Z is 1.92. This question is not related with the one we are doing earlier on. No. I just picked and said, how about when our Z is 1.92? So go to Z where Z is 1.92 is here. You'll be able to read this. 0.4726. 0.4726. 0.4726. We finish one thing at a time. When are we subtracting? 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 This kind of a scenario now. Now, you see, when you are given a table by Qn5a, nowadays Qn5a has got these bad manners of giving tables that are not consistent. Too bad on Qn5a, but that is an egg on their face. Too bad. Too bad. At times, it will be very important for you to look at the kind of table that you have. We have got two types of tables here. You will get other examiners giving you the cumulative. You will get other examiners giving you the cumulative, where they shade like the bigger. Wala ambao wamesema 0.99 hawa kuna cumulative normal table. Is that true? Is there somebody who has got a table? Kule juu amekuandikia, wamechora kitu akiwa ka shade area kubwa. Iko mwanafunzi ana table kama hiyo kweli? Wame shade area kubwa. Yes. Yes. So hiyo nayo ni table mzuri sana. Unaona kama ilikuwa yetu hapo ilikuwa ni 1.92, si ndio? Sasa wewe utaenda straight away useme entry kama yako ni hiyo entry. Useme entry. So ukisoma entry inasema ni ngapi somebody? 1.92. Entry yake inasema 0. Hii accumulative hiyo. Entry yake inakuja ngapi? Pata potea. Entry yake inakuja 0.9726. Now, because this one here is cumulative, and you want the small area, then the smaller area here, which in our case was shaded, the smaller area will be obtained by taking 1 minus 0.9726. Now you work with 1, not 0.5, because yours is total cumulative from the beginning. From the beginning. But ile table mzuri ni ile ambayo sio cumulative, ile ambayo wameshade, ile ambayo ile wameshade hapa peke yake. Yenye wameomit 0.5. Omit 0.5. Ladies and gentlemen, I've passed my point across. And if that is the case, I would want to go to something different. When do we use X bar? And when do you use mu? Ladies and gentlemen, remember, this one is the normal probability computation. The normal probability computation, we normally talk of Z being equal to X minus mu divided by standard deviation. That is a normal. That is a normal. That is a normal. That is a normal. All right. All right. But when, for example, you want to get like a sample probability, when you're doing hypothesis testing, then you come and say Z equals X, for example, minus X bar divided by what you call the standard error. But these are too detailed for you. Joyce, I don't know how I could make this thing much easier for you. I think if you watch the video, perhaps later on you'll be able to pick up something. After all, right now it's helicopter. I don't really need to keep on staying on one thing. No. That's going to be the objective. Sec 3 FM. We shall overcome. We shall overcome. We shall overcome. We shall overcome. So can I move on to something different? Or you want Mwalimu to... Can I move on to something different? We can't afford to stay on one thing. Trust you me. It will be counterproductive. It will be counterproductive. Okay. So we go to November 2019, question number 4. November 2019, question number 4 is a real estate question. November 2019, question number 4, boy. November 2019.